Hi guys, welcome back to a new video. In this video, I'll be talking about anemia and its classification. So, anemia. Why anemia happens? So, the amount of iron present in our body kind of decreases, and what iron does, it holds hemoglobin in their body. So, decrease in amount of hemoglobin and decrease in amount of hemocrats. So, hemocrit. So, maybe you might think, what is hemocrit? So yeah, to 120 to 120 grams per liter is female's amount of hemoglobin, and 140 grams per liter is males. So RBCs has three things: hemoglobin, oxygen, and lactate dehydrogenase, which is an important enzyme that is present in. I'll be talking about that later, but keep that in mind that there's lactate dehydrogenase there. So how can someone see and categorize anemia? Basically, they see is what they see is mean corpuscular volume. What is, you might think, what is mean corpuscular volume? So is nothing. The thing is, it just determines the size of RBCs, and through that they can determine what sorts, or they can classify the what sort of anemia you have. And yeah, that's it. Like, it's nothing more than that. It helps you just classify anemias in three categories. So yeah, maybe there's decreased anemia, right? Another way is to classify. There are many different ways, but one of these ways is, like, another way to classify is decreased anemia. There's bone marrow disorder, like acute nephritis, chronic nephritis, chronic kidney diseases. Okay, so this can be this can literally decrease the process of erythropoietin. Erythropoietin again is an enzyme which triggers erythropoiesis, which is called as RBC formation of RBCs. Hypothyroidism again, anti-repituitary glands, and this kind of regulates the whole system. Like vitamin B12 deficiency again, pernicious anemia. Yeah, because of that, iron deficiency can't iron just can't be absorbed, right? So yeah, iron just can't be absorbed from the gastric system of our body. So definitely because of this, iron hasn't been absorbed. There's chronic inflammatory diseases. Inflammatory diseases, what it it reduces, technically it reduces the lifespan of RBCs. So the main category right now I'll be talking is anemia itself. So anemia can be divided into three different types, and this is done by MCV, which is mean corpuscular volume, which determines the size of anemia. So one is microlytic anemia, which is less than 80 of Farman logs. Yeah. Then there is normocytic anemia, and then there is macrocytic anemia. In this, iron deficiency takes place. It is chronic inflammatory disease, and it can lead you to thalassemia. If these three sorts of things are happening, so definitely one of them is the reason why you the type of anemia you have. You get it? Yeah. Normocytic anemia, which is 800 to 80 to 100 Fallon laws, and depends upon your reticulocyte count. Now again, reticulocyte, you have to see the videos which I have uploaded in the previous channel. So there's this thing. There's overloaded reticulocytes count, and there's less loaded, no, less amount of reticulocytes, less reticulocyte count. Hemolytic anemia, which is again blood loss, which leads to blood loss, and reticulocyte least amount. So this is definitely bone marrow diseases, disorders. One of them is aplastic anemia, which leads you to there's the production of RBC reticulocytes in the bone marrow. Is there's this gene which triggers the production of RBCs. Macrocytic anemia, which is more than 100, definitely more than 100, and you can actually declare it through blood film, like keeping a cascade over it. Okay, megaloblastic and non-megaloblastic. You might think, what is megaloblastic anemia, right? Like megaloblastic is what? Yeah, I'll be talking about that definitely, and non-megaloblastic anemia. So, large immature blood cells, megaloblasts. Now you think now you guys might think, what is exactly this? Like large immature blood cell so megaloblasts only. This happens because hypertonic solution, and sometimes the size of a cell increases. This usually happens because alcohol consumption, like if a person is was doing this, and hypothyroidism, and during pregnancy, like this can determine the pregnancy. Like you just have to declare that. That's the reason why some females kind of face that pain and weakness in their body, is because of that. They have non-megaloblastic anemia, which is definitely temporary. It goes away when the child takes place, the fetus comes out. So yeah, large immature blood cells. This is basically megaloblasts, and these are hyper-segmented neutrophils. Hyper-segmented. What happens is like neutrophils are basically, they are one of those part of immune systems which can attack their own cells. This is known as autoimmune disorders. This there's a different video about it. Again, vitamin B12 deficiency, folate deficiency, and drug toxicity. Say, for example, methotrexate. There's another examples which I'll be talking about. I'll be talking about laterly. So now, if you have learned about hemolysis, I have already made a video about hemolysis, which is increased in destruction of RBCs. This can either be done in two ways: intravascular and intravascular. Intravascular is basically again blood, and extravascular is again reticular endothelial cells, which are present in bone marrow. Yeah, okay. Intravascular hemolysis, examples for them is like dis- dissegmented intravascular coagulopathy, thrombocytic purpura, hemolytic uremic syndrome, and mechanical heart valve. You will get to see that. I'm writing that as well. So yeah, thrombocytic purpura, thrombocytopenic purpura, which is decrease in the amount of platelets in our body. Hemolytic hemolytic uremic syndrome, and mechanical heart valve. Extravascular hemolysis is basically done by reticular endothelial cells. This leads to hypersplenism, hypersplenism. In this particular thing, like the size of spleen increases. This is because constant RBCs count decreases, and they have to kill most of the RBCs. And this is the grave of WBCs as well. Inherited hemolytic anemia and required hemolytic anemia. This can lead to malaria. Malaria basically, it literally kills up the whole process of erythrocytopenia. I'll be talking about haptoglobin. So what is exactly haptoglobin, right? So just imagine there's a hell lot of RBCs in your body, and they are dead now, just because a sort of an disease So what exactly happens is like dead RBCs are piled up, and they need something to be they so here the haptoglobin plays an important role. So because of this, like it starts clearing. So because of that, hemoglobin, due to hemolysis, hemoglobin in the body increases, blood is increased because hemolysis. And if you might have seen blood physiology, you'll know what exactly happens. So there are blood tests, and this might lead to hemolytic anemia. Again, there are some enzymes, which is one of them is increase in lactate dehydrogenase. Definitely lactate dehydrogenase. Yes, there's increase in reticulocyte count and increase in bilirubin, which leads up to the person to jaundice and makes the person's eyes and itself yellow. Haptoglobin are basically, you might think the amount of haptoglobin might go less during hemolytic anemia. And how is that? I'll tell you why. When too much of dead things are piled up, they are utilized in clearing up the RBCs. So the amount of haptoglobin is gone. It's like it's utilized there. Get it? So I hope you enjoyed this video, like this video, share this video, and if you have any sorts of doubts, just link comment down below. And thank you guys for watching this video.